YouTube, and welcome to another one in the series of New College Leicester Science revision videos, this time on nuclear fission and nuclear fusion. We're going to start off by looking at the grounds of a nuclear reactor. Inside a nuclear reactor, fission produces heat. This heat will turn water into steam, which is a gas. The steam will turn a turbine. This turbine turns a generator, which in turn generates electricity. Inside our nuclear reactor, we have control rods. These control rods regulate what is going on in the nuclear reaction to make sure that we don't have a catastrophic accident. The control rods are often made out of boron. These absorb excess neutrons and enable the reaction to continue safely at a non-critical level. Inside the reactor, we have slow-moving neutrons, which are produced by the splitting of other nuclei. These enter into the unknown realm of the nuclei, causing it to become incredibly unstable. This causes the nuclei to wiggle, and it causes the nuclei to wobble, and eventually the nuclei splits apart and releases a great deal of energy. This energy is a massive amount and causes the two particles to split apart and form two daughter nuclei and 3 extra neutrons. The mass before and the mass after are different, meaning that energy has been turned into energy. The 3 extra neutrons could go on to split 3 more nuclei, which could result in a catastrophic event, releasing a massive amount of energy. That is what a nuclear weapon does. Nuclear fusion is when 2 small nuclei are forced together to form a larger nuclei and release energy within the process. An example of this is when 2 hydrogen atoms are fused together to form a helium atom. This releases energy. It is a much safer reaction than nuclear fission to form in a reactor, as it cannot go as badly wrong. You'll see here the graph that shows how much energy is required to pull apart a nuclei, to pull the nucleons apart from each other. They typically sit at this distance away from each other, which is at an attractive force. If you try and push them too close together, they start repelling. If you pull them too far apart, they actually try to pull themselves back together again. As the separation becomes bigger, they are more likely to leave each other to create 2 separate nuclei. This requires a very high temperature and a very high pressure to enable them to be forced together like they do, which is why it is such a hard thing to reproduce here on Earth. We can see here a comparison between nuclear fission and nuclear fusion, being that fusion, the nuclear reactor, as well as in fission, it takes place in a hydrogen bomb. This method releases far more energy than nuclear fission. The fusing together of hydrogen causes the formation of helium. This is a process which happens naturally within stars. It has an extremely high temperature and a high pressure to enable it to take place. Producing this reaction on Earth is very difficult due to the conditions that are needed for it to happen, and this method could be used to generate electricity in the future, and it could replace conventional power stations. Nuclear fission, after 12 cycles, has produced 531,441 atoms which have been split apart. The bombs dropped in Hiroshima and Nagasaki during World War II used this reaction. Uranium-238 is used in this reaction to generate heat to therefore create electricity in a nuclear power station, and the chain reaction can occur if it is not controlled in a sensible way, causing a giant nuclear explosion. Control rods are used to reduce the number of nuclear neutrons that are there and reduce the amount to stop this from happening. And it involves the firing of a neutron, which makes the nucleus of a uranium unstable and break down and release energy. I'll leave this comparison on the board for you for a couple more minutes so that you can see it for yourselves. Thank you.